This is our second video, which is talking about word example. In this video, we are going to try to answer the following questions. Determine all horizontal and vertical asymptotes that the function f of x may have. This is one of the fundamental questions in Calculus 1. Now, how we are going to proceed to answer such a question? Now, we have two parts in this question. It's asking about the horizontal asymptotes and the vertical asymptotes. Let's start with the first part, which is talking about the vertical asymptotes. In order to talk about vertical asymptotes, first of all, you need to know what is the domain of your function. Recall that you could write your function f of x as 1 minus x divided by the factors of the denominator, which is going to be x plus 2 and x minus 1. Why did I write it in this way? Because that's going to make it easy for you to see the values where your function is going to be undefined. So from here, you could see that the domain of your function is going to be all real number except the zeros of your denominator, minus 2 and 1. That means that x is equal to minus 1 and x is equal to 1 are vertical asymptote. Well, there is one more property they have to satisfy to be vertical asymptotes, the limits. The limits should be does not exist. It goes to infinity or to minus infinity for the line to be a vertical asymptote. So let's try to evaluate the limits for both values when x approaching both of these values, minus 2 and 1, and to see. If the limit exists, then x is equal to that number is not going to be a vertical asymptote. But if the limit does not exist, that means we having a vertical asymptote. Let's start with the first value, limit for the function f of x when x approaching 1. Now, in this expression, you will see that you have a cancellation between the numerator and the denominator if you are taking minus 1 as a common factor from your numerator. That means limit when x approaching 1, after the cancellation you are going to have minus 1 divided by x plus 2. The value of this limit actually is going to be minus 1 over 3. So we can't consider x is equal to 1 to be a vertical asymptote. So what do you think that we have in the graph of this function? Well, when we are approaching the point 1, you will notice that your function is not defined that x is equal to 1, but the limit exists. That means on the graph itself, as you are going to see later, we are going to have an open circle. Let's move now for the second point, minus 2. You will notice that the limits when x approaching minus 2 for the function f of x, then if you're taking the minus 1 as a common factors from your numerator, then you will find that this limit does not exist. Why is that? For more elaboration on that, you will find that if you wanted to evaluate your limits from left, then the value of your limits is going to be infinity. And when you are evaluating the limits when x approaching minus 2 from right, then the limit is going to go to minus infinity. So since the limit does not exist for when we are approaching this value, that means the only vertical asymptote that this function may have is going to be x is equal to minus 2. To answer the question fully, we need now to find horizontal asymptote if they exist. Now, to find the horizontal asymptote, you need to evaluate your function, the limit, when x approaches infinity or minus infinity for your function. So in the first case, to evaluate such a limit like this one, we are going to multiply and divide by 1 over x squared, where x squared is going to be the highest power of your denominator. That will yield, that is the value of this limit is going to be 0. Also, if you evaluate the limit when x approaches minus infinity for the same function and doing the same trick here, you will find that the value of this limit is going to be equivalent to 0 as well. That means the horizontal asymptote that this function may have is going to be y is equal to 0. Now, if you are interested and curious to know what is the graph of your function is going to look like, then it's going to look like this graph, except that notice that your function is not defined at the value x is equal to 1, but the limit exists. So that means in this curve, we are going to have an open circle at x is equal to 1. And the limit at this point is going to be minus 1 over 3. Also, we have x is equal to minus 2 is going to be a vertical asymptote. Notice that if we are approaching the asymptote x is equal to minus 2 from right, the curve is going to go to minus infinity. And if we are approaching the asymptote x is equal to minus 2 from left, then the curve is going to go to plus infinity. That's why we have x is equal to minus 2 is going to be a vertical asymptote.